All right, so on this slide, what we want to do is we just want to graph the cosine of theta, and I'm going to use a strategy, okay? So what we did in the last slide was just to give you an understanding of why the cosecant of theta looks the way it's going to look. But at this point, all we really care about is being able to graph it. So our strategy is going to be, at least the strategy that most teachers use is going to be to graph the sine of theta. And I know you're probably like, Mr. D, why don't you just show us this strategy to begin with? Well, I want you to understand how you actually get the graph of cosecant of theta. This is just a trick, and I don't really like tricks, so I like for you to understand it. But tricks are kind of helpful, so we are going to apply this as we graph it. So y is equal to sine of theta. We know it starts at 0. We know that at pi over 2 goes to 1, then to 0, then to -1, and then to 0. All right, at this point, you should really know this parent function. Okay, next thing we discussed was that wherever the sine is going to hit 0, we're going to draw an asymptote. And that makes sense because the cosecant is the reciprocal of sine. So what's the reciprocal of 0? Well, it's undefined, so that's why we get those asymptotes. Second thing is wherever we see a peak, right? Wherever you see a peak in the graph. So here's your first peak. Okay, maybe my graph's not perfect, but at pi over 2, this should be the highest value right here of 1. So at this peak, wherever you see that, we're going to draw our parabolas, and they're just going to get closer and closer to the asymptotes, but they're never going to touch. And you just go up as far as the graph goes, right? And you go down as far as the graph goes as well. So we have another peak here, right? We see there's our other peak. And then we can go ahead and graph our parabolas. We know this is going to go down since it's negative. And that's it. There's cosecant, right? So not too bad once you know the trick. Again, you don't really need to know the table. You can if you want. I know that these are undefined, and then we have 1 and -1. But I think the graphing the sine strategy is the best. All right, let's go ahead and look at all the features of this. All right, so let's get a little bit of practice graphing y is equal to cosecant of theta. So we know that we have to graph sine out. So really quick, I'm going to graph sine. Whoops, that looks kind of weird. So sine, it's going to look like that. There we go. We know that wherever we have a 0, we're going to draw asymptotes. And wherever we see a peak, we're going to draw a parabola. So there's a peak, parabola, there's a peak, parabola, here's a peak, parabola, and here's a peak, parabola. Perfect. And there's our cosecant graph. So now we've got to identify the domain. So the domain of this guy, so this is, cosecant is a little bit interesting because, or cosecant and secant are both interesting for this way, because even though they have the asymptotes that split it apart, this entire thing is still considered one period. Right, this is still considered one period. So if we were to continue this to the right and to the left, you would see these periods continue, right? You would see another period would be there, right? We'd see another one up here, and they would just keep going. Okay, so, but we're just focusing on just one period of this, right? So when I'm talking about the domain, I'm only talking about one period. When you get into your math class next year, you're going to talk about all the periods. But for this one, just one period. So we know that your x values, our x values are going to be, now this is why interval notation becomes really helpful, because when you start to do this as an inequality, it gets a little bit tricky. So we know the x values are, the first pair of x values are in between, whoops, they do not touch 0, are in between 0 and pi, right? We can see this is the first piece right here, between 0 and pi. All right, and it is also the piece that is in between pi and 2 pi. So it's going to be both of these. All right, both of these together is going to be the domain. All right, that's the first piece, and then this is the second piece. The important part here is the fact that the inequalities do not have the equal signs under it, right? So that's why it never equals pi, it never equals 0, it never equals 2 pi. If we were to write this in interval notation, we would just write from 0 to pi, and then we would write this sign which means union. That just means I'm including both of them. So union pi to 2 pi. So what the way we would interpret this is cosecant has values between 0 and pi and between pi and 2 pi. All right, and that's it. For the range, all right, the range of your y values, right now I'm only looking at the graphs in the red, right? I'm not looking at the black, I'm not looking at the parent function of sine. I'm only looking at this piece, and I'm only looking at this piece, I'm only looking at this piece, and I'm only looking at that piece. So think about what the y values are, right? Here's 1, and then here's -1, right? Doesn't the graph go above 1, and doesn't the graph go below 1? So then your range here is going to be all of the y values that are greater than or equal to -1, and it is all the y values, this should be, sorry about that, this should be y is greater than y is greater than or equal to 1, and y is less than all the values, y is less than or equal to -1. That's as an inequality. If I were to write this in interval notation, we would say from 1 to positive infinity, and then from negative infinity all the way to -1. Perfect. And then our amplitude, so our amplitude is still going to be the distance from the x-axis to that point. So this is still the amplitude right here, right? It's still the distance from the x-axis to, but this time it's not to the highest point, now it's to the lowest point, right? Or at least to the lowest point if I'm looking at this one right here. So our amplitude is still 1. Remember, it's always positive 1, so absolute value of 1, which is positive 1. My period is still 2 pi, right? It's still just like sine. X-intercepts, is this graph ever going to hit the x-axis? No way, right? Because, well, I mean, technically it could, but not the parent function will never, right? If I were to move this graph up or down, then yeah, but for this case, it's not. The y-intercepts for the parent function, none, right? It's never going to hit the y-axis. Intervals of increase and decrease, well, this is nice because there's going to be, it's going to be like half increasing, half decreasing. So let's look at the part that is increasing first. So if we look at the first parabola guy, this piece right here is going to be the increase. So that's increasing from pi over 2 to pi. So this is increasing from pi over 2 all the way to pi. If I go to the other one, this is increasing from pi, let's grab a different color, from pi all the way to 3 pi over 2. Right, that's the piece that's increasing. So union 3 pi, I meant pi all the way to 3 pi over 2. Now if we go to the decrease, right, this part is decreasing and this part is decreasing. So I'm going to have 0 to pi over 2 is decreasing, and then union 3 pi over 2 to 2 pi. All right, and we're all done. Let's go ahead and look at our last function, which is secant, and we'll be all done.